Hi, I'm Alison Davidson. Welcome to the Analytical Methods Laboratory at Staffordshire University. Today we're going to look at some of the processes that our students use when they're testing the sorts of drugs that will be seized from crime scenes. One of the key tasks that any forensic scientist has to get to grips with is how to test illicit drugs. Today we're going to have a look at some of that process, and our students will always start with a presumptive test, a colour test. Here I have a small amount of white powder and I'm going to use cobalt thiocyanate reagent as a colour test. A couple of drops added to the powder produces a blue precipitate. We can compare this to our chart of data and realise that one of the likely identifications for this drug is either heroin or cocaine. Our students would normally carry out a range of different tests on different drugs with different reagents. Infrared spectroscopy is a really widely used technique in forensics labs across the country. We're going to use it on our white powder today to get a further identification of it. A small amount of powder is placed onto the diamond stage and pressed against the diamond attenuated total reflectance crystal. The infrared light energy really interacts with the covalent bonds in the molecules and produces a spectrum. Once the spectrum has been collected, one of the great things about FTIR is that you can search against a library. And here we can see that the library has matched our unknown powder to cocaine. 61%. It's not a great match, so it might not be pure cocaine. We need to use another technique to further analyse our powder sample. Gas chromatography with mass spectrometry is still considered the gold standard technique for analysis of most drug samples. Our instrument here is heavily used by our students, and here are some samples that we've analysed. Our sample today, we can look at the chromatogram and see that as well as this main peak here, there's actually a couple of other small peaks showing on the chromatogram. Let's check out the main peak first. Mass spectrum will come up and that's showing us cocaine. So that's a positive confirmation for the presence of cocaine in our sample. We may run a standard to ensure we have the same retention time, and that would be considered very convincing evidence and allow us to charge our suspect, at least with possession. Let's see what else we can find out about the sample. If we look at the chromatogram and look at some of these smaller peaks that I've now zoomed in on, again, bringing up the mass spectrum here and searching against the library, we can now see that this sample has been cut with lidocaine. This will allow us to potentially link a dealer to a whole set of samples that's seized from different users and potentially bring better charges against our dealer. This is really useful information. We're active in research here at Staffordshire University and working with local prisons to analyse not only drugs like cocaine and heroin, but more specifically some of the novel psychoactive substances like spice that we're seeing going into prisons today. We quite often see that with drug usage and in fact drug preparation, there are different trends in the chemicals that are used as cutting agents and adulterants. This is important research, and here at Staffordshire University we have a number of research projects which might involve, for example, collecting samples that have been handed into the amnesty bins at a local festival, analysing them to see which trends we can discover. We also have researchers working with local prisons. The focus here is not so much drugs like cocaine, but rather the new psychoactive substances things like the spice that you may have heard about. And we're working closely with our local prisons to identify some of those new drugs which we've never seen before and which we need to be on the lookout because they have such a devastating effect. That's some of the research we do at Staffordshire University. I hope you found this interesting. Thank you very much.